Thank you very much, Catherine. Thank you very much also, Laura. I can completely concur with pretty much all of that right off the bat. But, well, right. So I'd rather like to focus on the perspective of a PhD student, of a PhD researcher, looking to maybe join the program, why you might want to do that, right? So to situate yourself as well there, I'm currently in the third year of my PhD, and I'm effectively attempting to predict the evolution of active regions. That's the combination of black and white blobs on this image here, which unfortunately is A, rather difficult, but B, rather vital to our understanding in space weather and space weather prediction. Overall, linking that to what's happening further up in the sun. That then decides how we can make sure that any satellite we might put in orbit, any electric grid we build on Earth, might best survive in case of stronger events. Now, if I wanted to, on my own, go through with it and with this and try and build a full-on project that starts off where I am right now and then goes through the entire predictive cycle, trying to directly predict any space weather coming up before it happens, then quite frankly, the avenues are massive. There are a lot of different options in which I can go there, but unfortunately, as I'm assuming many of you will be well aware of, the time and the resources available in a PhD are very much not that vast. So chances are, quite frankly, the required funding for full extension to this end alone will need up quite a bit of time. That's assuming you can get access to the hardware, and that's also assuming you even know how to best use it. And next slide, please. Catherine, can we move on to, yeah, thank you. Problem is that on top of all of this, right, even though it is a vitally relevant task, it turns out that actually it becomes increasingly more important to get this right quickly, since we are currently approaching one of the solar maxima, so a time period where the sun's energetic output essentially reaches its maximum. So when storms, for instance, are the most likely to happen, that's displayed here with the sun symbols, where two of them display previous solar storms of particular intensity that directly impacted electric grids on Earth. As long as we can't really predict any of these storms accurately, they might as well be just around the corner, quite frankly. Because at the moment, essentially, all we can really do is try and detect them very quickly and then hopefully properly predict how exactly they're going to potentially cause any issues for Earth, if they are going to be causing any issues at all. Fortunately, one brain alone just isn't going to cut it for a problem of this size, especially not on a shorter, ever shorter time scale. So an opportunity to spend time just on the science directly, working with modern technology, state-of-the-art hardware, knowledge from brilliant people from different strokes of life among the top of their field, is, from my point of view, absolutely the opportunity to move on. It's a team sport after all. So let's take a look at what we've done in 8 short weeks. So as mentioned, really predicting these eruptions is a thing of the future to come. For now, the best we can achieve is quickly noticing when events happen, correctly deducing what will happen if there is a hit, if there is a potential hit at all. So we tried in our 8-week sprint to do exactly that, to extract 3D structural information on solar eruptions and predict how exactly they are going to evolve through time from simple 2D imagery alone, something that we were repeatedly told would not be possible to begin with. Though, quite frankly, from the looks of it, we were fairly happy with how far we have gotten in the time frame. Hopefully even able to get some level of that potentially ready for use with future satellite missions, such as the ESA Vigil satellite, currently slated for launch in circa 2030. Well, of course, our work is based on that of many others, for instance, including results from the FDL in 2022. I've already noticed that Benoit is currently also watching. He was on that team. And there are still avenues to take the project further as is. Still, we are quite happy with how far we've gotten in those 8 weeks. Though, to be fair, I do have to stress how difficult these 8 weeks really can be. I mean, Lauren Paul also in the chat right now, I'm pretty sure that they can concur on that point. But quite frankly, it is so worth doing. To go into a bit further, actually, so looking at our team consisted of 2 physicists, 2 computer scientists, in Halle and German as computer scientists, Emma and myself as physicists, led by 3 wonderful team leads. One of them unfortunately couldn't make it in person for an image. And just a pure opportunity to work with those brilliant people from different strokes of life, from different experiences, combine all of that into one focused project, and then iterate rapidly, working through different opportunities there, was absolutely a fantastic experience. To highly recommend it if you do get a chance to apply. Do so. If you do apply but do not get chosen, apply again. That's what I had to do. It's perfectly normal. It happens. Because quite honestly, this is a excellent experience you can not really get anywhere else. On top of that, all of our research is currently available on the FDL website. That's linked in the QR code here. This currently links to the same point that was put in chat earlier, which forwards all of the research results we've had from FDL Europe over the last year.